So I am Devraj Singh. I am BTech third year aerospace engineering student at IIT Madras. So my project is riverine flood module for tropical major basins, where we are supposed to make a flood hazard assessment framework. We'll be focusing on the five deltas in the tropical region. That is GBM, Ganga Brahmaputra Meghna Delta. The other is Krishna, Godavari, Mahanadi. Mahanadi and Iravadi. So these deltas receives an intense amount of monsoon rainfall, especially in the months of July and August. That can cause a high level of water discharge that can affect the dense population that lives in the low-lying areas. So despite their importance, many of the tropical river system have been less studied when it compared to the temperate river systems. So the question that we'll be trying to answer is how often do these deltas flood, and what is the depth and the extent of the flooding? So to model a flood, we need to model a flood, we need three parameters. The first one is the elevation of the land and its slope. Second is the water column that is present over it, and third is the water discharge. We have global data sets available that can provide us with that. After that, we have two options. First, we can go with the physics-based approach, which is like, for example, list flood, in which we'll apply some physics-based equations like inertial equations and computational fluid dynamic equations, discrete equation that can help us to model the flood simulation. The other one is the data-driven approach, where we'll use the machine learning techniques to train our dataset on many deltas and then get our results. So what the novelty of this work is that there are many studies that are available for the temperate region. For example, there's a LSTM study in the US where they have trained their dataset on more than 500 deltas in the US river systems. But there's not much of the study that is present on the tropical river system, which have its own very unique problems like monsoon and the climate variability. Then, rather than focusing on the one river, we'll be focusing on the five delta systems that can help us to compare the similarities and the differences between them. That can basically help us to do a comparative analysis to understand the tropical systems better. So our modeling workflow is going to be, first we'll take the 20 or 40 years of historical data to get the frequency analysis, which basically is the probability each year, what's the probability of flooding of that particular delta. Then using our data sets, we can and the historical data set, we can get the boundary conditions. We need boundary conditions to close the system of equation that we have in our physics. And after closing the equation, we finally can get the flood simulation, and we can validate it using our historical from the data we have using the historical satellite data. All right, so our stakeholder and what's exactly is the application of this project is for sure is the best application is for the disaster management authorities like NDRF, this model can help them to plan a better evacuation and prepare them for unforeseen circumstances when there's a heavy flooding, to evacuate the people from the low-lying regions where there are chances of the flood are more. Then, of course, for local communities and urban regional planners, for example, there are PWDs and all that, they need to design infrastructure near the river systems. It can help them to make better infrastructure, as infrastructure can reduce the risk of lives and properties a lot. Next is the agriculture sector, as there are many farming sector that is depend on these river irrigation from these rivers. So the flooding can destroy the crops. For example, it can uproot the crops, or it can prevent the oxygen from reaching the roots. It can suffocate the plants. So that can cause the mass crop destruction. So, but having this model, the farmers might be able to prepare better. Next one, these rivers receive most of their water from glaciers that are present upstreams. So their discharge, when we have the data set of their discharge rate, we might be able to predict what are the melting condition of the glacier. So it might help the climate change adaptation agencies to manage the climate change. All right, so to conclude, I would just like to say that our long-term goal is to contribute to a validated riverine flood module that can take care of the conditions that are localized and that are unique to the major tropical river systems. Thank you.